Hello everybody, Michael here, and today I'm going to talk to you about software documentation. And is it really needed? Um, well, I will argue, or I will provide you with a set of tools that makes that real easy for you. So let's hope you benefit from this and move on. So my agenda today will be to talk about code and comments. I will start there, and then I will talk about how we can generate documentation, API documentation, and UML documentation. And generate is easy, so here we can save a lot of time and effort. So stay tuned. I will also talk about version control and emphasize that that is an important part. And I will also talk about the aspect of semantic versioning in line with doing versioning control. Okay, so hopefully when we are done, I will have you a toolbox that will enhance your environment and productivity as a programmer. Well, let's see. I had a friend once, a colleague of mine. He always told me that code is king. Okay. He was a bit black and white, so he wanted to emphasize that yes, code is the most important part. So when you talk about documentation, Michael, it's secondary or none. We must focus on the code. I don't know if he was right. I know he was black and white, and I'm more of a grayish person. I say, well, it depends. So I won't give you an answer to this question right now. So I think instead, stay tuned and follow me through here, and I will talk to you a bit about bits and pieces that would actually make documentation make sense, and I will make it easy for you also. I will try at least. So the things we have here is, oh, sorry. Let's start with the code first. So I want to sort of emphasize that if we should really try and learn and do our best to write good and clean code. And when we do that, that code is for me easy to read like a book. It's easy to understand and grasp. So I really want us to write the code for readability. It should be easy to read it like an open book. So we shouldn't think about being clever when we write our code. That is not the way. So think about readability. And I think that is the main aspect when we write our code. Really. So be structured, work with code standards, format your code for readability, and ensure that the code is really readability, not just tomorrow or next week. It should be readability in 3, 4, 5 years from now. So think of that and think of what's necessary. Is comments in code, in good code, really needed? Well, maybe not. If we really write good code, it should be self-explanatory. So what about comments in code? Should we actually do them? Well, some say don't. But when we do it, so of course we have the ability and opportunity to put comments into our code, so we should use it. But the comment we put in there should make sense for myself and my fellow programmer. It shouldn't be sort of explaining the things I can see in my code. Perhaps it should be explaining the larger picture. Or if I have written some very complex code section, perhaps I should give an headline and just hint out what am I doing here in large So not in details. I think you should remove unneeded comments because that's hindering the code readability. So remove it if the comment doesn't give you anything there. But use them when the code flow is hard to grasp. You could also use it to describe the basic intention of the file we are in, or the code, or the class, or the module, or the method. So feel free to give a headline for each of those. So good and clean code. Maybe they don't need too much comments. Okay, think on that. And right away we go into a new slide saying we should do comments. And this is Docblock comments. These are a bit of special comments that is available in many languages. They may not be labeled as Docblock comments, but this type of comments is the specially formatted comment, usually visible on file level, or on top of the module class, or on top of each method. The general contains a short description, and we can add details about incoming parameters, return values, and additional details perhaps that is not visible in the code. There are sort of programming languages that are not, where the type is not visible when we send an argument into a function. And perhaps we could use a Docblock comments to show off what type we expect there. These Docblock comments is easy to parse by external tools, and this makes it possible to use them for static code analysis. So the static code analyzer can read both my code and the Docblock comments and sort of match them together to see if it makes sense what's stated in the comments. So it's basically also linting my comments, and that's a good thing. Another thing we can use Docblock comments for is to generate documentation of the code. So we can take both the information from the code and from the Docblock comment and put it together to documentation and generate, for example, a nice website with HTML pages showing off my sort of code and make it searchable. So here is an example of a Docblock comments, and we see the function at the bottom there, and it's a valid move, and we see the parameters, and then we see that on top of the Docblock comments we have a sort of a short description, and then we have the parameters and then a description of each parameter, and then we have the return value. So it's sort of a complementing the picture of the whole sort of method. Here we have another example, a bit smaller one. We have the short description on top. We have the parameters list with the description, and we have the return value. So these are Docblock comments, and they may look a bit different depending on your programming language, but they are usually an available feature for you to use. So I think it's a good thing to use these. And yeah, Docblock comments are good for many reasons, but there's a good way, structured way to document your code. But when we want to generate documentation, it will be much easier when we're using this Docblock comments. The tools we generate, and there's a lot of tools out there depending on the programming language we use, they sort of get the information from the comment and from the code and sort of generates it up. So it's an easy way to have a up-to-date documentation of the latest code base I have. So these are the general overview what we getting from such a documentation tool. We got a description, overall description on the file, on the class module, on the method. We see what type of methods, the parameter list, what the return types are. So we get a complete API doc. And some will think that it's easier to review the documentation on a website than having access to the source code and reviewing it. And sometimes you don't have access to the source code. You only want to use the public API of a module. And then perhaps it's easier to review that public API through a documentation website. Here is an example of this documentation websites, and just showing a class and the details of the class, and it makes it pretty much readable, easy to sort of get into the details, and sometimes it's easier to use this than go into the code. There might be a risk of over documentation when we do this. If we have the same thing in the sort of method, the method description, and in the Docblock comment. So we have the same thing on two places, and we forget to update. We update one and we forget the other one. That would be a bad thing. We really want to keep our documentation and code dry, so we don't want to repeat ourselves and have duplicated information. So when we use this Docblock comment, we should only sort of try to add what is not existing in the code. That would be the optimal way of doing it. See the point, the documentation takes more time than coding. Yeah, one would say that, but I think we could, when we sort of adapt doing this Docblock comments, it will be a very easy way to just add them on top of each method. It will be in the sort of back of our spine, and it's there in our working process. So no, I don't think it's too time consuming or hard, but you must do it out of, well, it's just a thing I do and I do it normally. It's not an issue for me. Then we're sort of having a great mindset for working with this. So let's see the summary we have this far. So I say, write easy to read code, good and clean. Documentation, we use comments when needed. We use Docblock comments, sort of explain what's missing and giving the overall picture. And we generate the API docs automatically. I think that's a good start. What about the analysis and design documents? Well, we usually do this prior as some kind of artifact before we actually do our code. So they're good starters to get going and knowing what we're supposed to develop. But when we actually start developing and writing our code, we in general don't go back and update our design documents. But still, it would be nice to have these as a documentation for our application. But how should we do that without the extra effort of going back and updating them? So I think we should start with one A4 or 2 pages perhaps that could be giving us the overall picture of sort of the main elements of my code and how they interact. It provides an entry picture for the person who is going to dive into my code. So I only mention the most essential part there, and then the person can go into the code and look, or in the API documentation. So I don't think we should underestimate a simple A4 with a picture, some text, just the main picture. I think this is a good thing. And one A4, yeah, we can sort of keep that updated. That's not so hard. But when it comes to the analysis and design documents, I think we should generate those. And we should generate those from our current code base, so we always have them up to date. And there exist in general a good setup, there exist tools for, in general, any programming language. So you can generate UML images and diagrams from the source code. So you get class diagrams, perhaps use cases, perhaps diagrams showing how the different objects or classes interconnect to each other. And we always get the most accurate images of our code. So this saves time, makes us focus on the code and generate these UML diagrams and use them for documentation, because they might be very good to sort of dive in and see how the program works together. This is a image from a generated UML diagram. It's from, seems to be a Python program, and it just shows how the classes sort of interact with each other, their overall relationship. And well, I would prefer to generate this with a simple command than keeping this sort of sketch updated from the design phase. I, in general, don't do that. So generating UML sounds very good for me. Good. So, summary this far again. Readable code, comments when needed. Docblock comments to explain what's missing, and we generate the API docs from the code comments. We generate the UML from the code, and we might keep an A4 updated on the overall picture of what our program is doing. Good. Let's move into the version control. And version control basically is a way to keep our code, well, what should I say? Well, it gives me code history. It gives me the opportunity to save each change in my code base. And I could sort of get in history, and I could go back in the history and see what I changed 1 year ago, 2 years ago. The history is complete. So I get this, and I guess Git is one of the most common software version control systems that we are using today. Subversion, SVN, or other, and there exist much more these versions systems. They are version control for source code, and the basic idea is that each change to the code, each feature perhaps, that we add or fix, we do a commit. And when we do a commit, we sort of write this change into the commit history. And then we sort of have a list of all sort of a history of our code, where we could actually sort of check out that code, or the commit relates there. I want that version of the code. And these commit messages is a message that gives us a history of the code base. So I can basically read each commit message and see what has happened with the code. And that is might be very useful when you try to debug, compare different versions, or even, like it says there, blame someone for having introduced the bad, faulty part of the code. We can sort of find exactly which person did this commit at what date and time. Very useful when you're working with code. So what we also do with tag base, so when we are happy with a bunch of commits, we say, okay, I'm happy, I'm going to release this now. I have a stable base that is working. So then I do a tag, and a tag is basically a version number that is, or a tag name that is attaching to a commit ID. So basic things about version control for source code. Here we can see, let's review some pictures on how it can look. So here's a commit history, and here we see different commits made to a software. And you see here that the commit message, the controller method initialize, can return a response useful to. So we make crisp and often short messages. What did this commit fix? So this commit history is actually It's quite important, and you will know when you try to read a commit history from your friends to really see, can you get a grip on what is actually happening in the code here? And you should write out from the commit history. Well, this is just some fun strip on what will happen when we write bad commit messages. And yes, we can find projects having these bad commit messages, but we try to avoid them because this commit history is really, really important for our code base and a very useful tool. So keep that updated in a good sense. We when we do these tags, I said we do a tag on a stable base or software. We usually do. So now I'm done. Let's release this. Let's release this for test, or let's release it to our customers. We should use version numbers. For example, version 1.2.3 or 1.2.3. So we should also add these numbers with some kind of meaning. And I will talk about semantic versioning and the importance of that. But semantic versioning provides a meaning to each of these figures and will help us by only reading the difference. Okay, I got release 1, 2, 3. And now they are releasing version 1.2.5. So I could actually imagine what has changed in the code from just reading the version numbers. So that means that the semantic versioning system, it's a system that is sort of describing how you should do it. It has a meaning, a semantic meaning. So we have here major minor patch and relating to this figure. So when we do a major version change, so going from version 1 to 2, or from 2 to 3. That means it's a major version and it's it doesn't need to be backward compatible. So the API might change. So it's a large change. When I change the second figure, so 1.2, 1.3, 1.4, 1.5, that is a minor version, and I'm adding functionality. So I'm adding features, functionality to the code base, but I do not mess with the backward compatibility. It is still backward compatible. So I can basically upgrade without risking that my system should break down. That is the basic intention. The last figure there, that is the patch version. So it's the third one. So 1.2.3, 1.2, 1.2.5, 1.2.14. So this means that we have made some smaller fixes or patches to the code, and it is still backward I can't really say that word. Backward compatible. Thank you. So, and I will show you. Hang on for a few slides. I will get back to you why this semantic versioning might be a very important thing to sort of know. But let's stay tuned. So here is the release history that is sort of I can provide, showing off how my software has grown, what versions I have, and what have changed within them. And this could be a document in the Git repo, if I say so. Perhaps a releases.md file where I just note this, and I could note the changes each time I do a commit, or I could keep have good order of my commit history. So when I'm going to freeze a new tag, I just take the commit history from the latest tag and I add that, and then I see what has actually changed. But it's good to keep this updated and keep it updated when I'm working with the code. Could be a good thing. When I this is a example how it could look like when I release something on GitHub. So GitHub or GitLab, these web services where I can release my Git repos, very popular and have, well, they have actually done a lot to sort of make it easy to work with Git version control, or Git repos, as we say. So this is a way where we can release our software on a GitHub here. And this is a tag. So the tag, when I do this tag, I provide a larger commit message into this tag. And then this commit message is displayed on GitHub as a release. And it provides also a sort of basic documentation and readability to my code. And that is very useful for the ones who are using my code. Let's get back to this why semantic versioning might be very, very important. And it depends on, well, it relates on when we are using external packages or modules. And these are then managed by version control. And they have version when they release new features or fixes. So if they release according to a well-known version sort of system, like the semantic versioning, then I could depend on that when they have changed the third figure, that is just a patch release and it's backward compatible. When they have changed the second release, I know they have added features, but it's still backward compatible. And when they change the first figure, I know it's a large release, it's not necessarily backward compatible, and it might be harder for me to upgrade to the newest version. So it becomes some kind of contract between me and the developer of the model. And this contract, if the developer there says, well, I'm following the semantic versioning, I'm doing my releases like this, so you can depend on me. And then I sort of can decide what releases. Do I only want to get when they change the third figure, or do we also want to get the feature updates when they change the second figure? So I can make decisions based on relying on the versioning number. So that's why this version constraints dealing with that. That's why it's very important that you know how the version numbers is managed. So here is just a sort of example of how version dependency can work on. This is sort of one kind of software that through its sort of package installer is sort of deciding what are the version that I'm going to use here. What is the first primary version, and how sort of can I, if there is a later version, should I use that? Should I then rely on the third figure or the second figure? How should I relate to that? So version number is important, and you should use version number in a controlled manner so we know what each change in version really means. So I think we are closing up here. Let's say something about documentation in the whole or in the large when it comes to sort of software projects. If we were involved in a large project, there will be a much more perhaps developer documentation, perhaps inspection review, or where we sort of review the documentation and we sign things, perhaps items or documentation we can throw away, but they might be useful during the project. In the project docs, we could have test plan or different type of reports. We could have product documentation like requirement specification, feature specifications. We could have documentation that is aiming at the user. So the user should understand how to work with it. We could have documentation specific for training, specific for installation, specific for marketing and selling our products, specific for supporting our products. So it's a lot of different documentation that might come into be real needed and necessary or important as a whole or in a large. So we shouldn't forget about this whole picture. What I have actually sort of emphasized today was the part of documentation that me as a programmer, if I'm a good programmer and I adapt some small techniques and some small tools, I could sort of become a better programmer and supply my organization with sort of better code, better documentation, easier to use for me and my friends. Okay, so let's try and sum everything up here for one and final time. What have we talked about? So I've tried to emphasize the meaning of good, clean code as readable code, where we do comments when needed. I also say that we use the concept of Docblock comments to explain what's missing, and that will also help us when we want to generate the documentation for our code from these sort of code and Docblock comments. We do generate UML diagrams directly from the code, latest version, accurate, and perfect with my latest change. Then we might complement this with an A4. Just architecture sketch overall, some main parts where I want some new programmer to dive into my code and see how it looks like. So it's easy to sort of, usually maybe you don't need to maintain it, because when you have written the overall thoughts, maybe those are sort of stable. We should all go for version control, use Git or any other versioning control. We should really build up the commit history. We should use tag, do releases, have a release history, work with the versioning. And we should have some sense when we do versioning, some type equal to semantic versioning, where each figure has a meaning. So do all this and adapt this into your everyday work environment, and I'm sure this will make you a sort of better and more productive and reliable programmer developer. So this is good. Do they really use this out in the industry? Well, as always, it depends. If we take a large company doing software products, releasing to major customers, earning sort of a lot of money, yes, they will do a lot of documentation in project size, product size. It will sort of end user documentation support. Yes, it's a lot of documentation, and much more documentation than the one we have talked about today. If we take a smaller company, perhaps 2-3 programmers working together, do they document? No, maybe they talk to each other and keep their up to date. It's easy to talk. Maybe they have less need of a documentation. Well, what happens when one programmer leaves the company? Yeah, the documentation leaves with him. The code is still there, but the thoughts behind it will leave. But maybe those smaller companies doesn't have the time or money to actually do a lot of documentation. So there we see sort of decreased efforts in doing documentation. I do think that a good programmer like yourself should be very aware of the documentation as a whole, and for sure adapt a set of tools like the ones we have talked about today. Tools and mindset when we're writing our code that sort of makes it easy to deal with documentation, generate documentation, readable code, working with versioning and releases in a good sense. So you should do that in despite what your organization is doing as a whole in in the documentation. So if you're good at it, you may be doing a difference for your company, and that is a good thing. When we talk about research matter, is this a viable research area? And I've put some topics here for title of research papers recently. And if I sort of give the whole picture of this is they're trying to research the area. Is it how much documentation is enough? And do the software engineers really use documentation? To what extent do they use them? Is it relevant of having too much software documentations or tools? So they're sort of trying to figure out how much documentation should we do? What is good and quality documentation? So it seems to be a viable research area. And if we think about it, documentation might cost money, but it can also be used to earn money, and it could also be used to sort of improve and doing an effective software production process. So, and when it's money to earn, that is sort of one reason why you sort of can work with research matters within this area. So yes, software documentation, pretty much researchable. If I should give you a hint on how you should proceed from here, it would be make doc. And make here, as in makefile, it's a sort of a build tool to run a larger set of sort of commands behind this. But when you can do make doc, you can generate your documentation and sort of add a small tool behind this that generates your API documentation. Good start. Then you add another tool that generates UML documentation. And then you make doc, and you always have the latest documentation for each and every single change in your code base. And that is really good, and it makes you a good programmer that wants to have sort of control and want to deal with sort of quality issues in your own production environment. So make doc, and once you have started, it's easy to add more stuff behind this make doc command. Try out other tools or add new ways of sort of generating views or automating your sort of checking your code standards and all this stuff. So move ahead with this. And there is the end of it all. I have talked about a lot about software documentation, both in as a whole aspect of developing large scale software products. Yes, we talked a bit about that, but my main issue was to do software documentation that you as a programmer can do in your small owned environment, in your own sort of use tools and write code to make it easy to develop this documentation as you move along in your code. Make it on a daily basis, and that will make it sort of easy to generate, easy to work with, and you will sort of avoid having to do, oh, I need to document my code and it will be the last thing to do. Well, I'm not going to end up there because I do this thing on a regular basis and I do it automated. So you know where to go from here. And that's all for today. And I see you in another presentation at another time. Bye bye.